It's a pleasure to be here. It's been quite a number of years since I've spoke at this particular conference. The last time I spoke, it was in Baton Rouge, so I don't know how many, if that feels like that was 4 years ago, but it might have been 8. Time goes by pretty quick. But my name is Jason P. Bond, and that says P _ bold. You guys probably know Jason A. Bond. So I'm Jason P. We were in grad school together at the same time, but I'm a plant pathologist and he's a weed scientist. So there's still some confusion. I still get emails from him. They're supposed to be going to him from time to time asking about weed science questions. So I just want to make sure that if you're looking for weed science information, we have all the answers, but we're not going to be talking about that. So you have to go find the weed scientist. So, and I have my colleague, Dr. Ahmad Fakori. We're both plant pathologists at Southern Illinois University. So I grew up in Louisiana. I got my degree at Louisiana State, so we're still happy. Big week. A big last 2 weeks ago. So and I've been at SIU for 20 years, along with my colleague, about the same amount of time. So we do a lot of work together. We do both applied research, very applicable to what management in the field, but also a lot of basic research. So we have kind of a joint program, quite a number of grad students and technicians. And we're also the lead principal investigators for the National Seedling Disease Project that is funded by the United Soybean Board, and also the Foliar Disease Project that is funded by the United Soybean Board. So we'll be talking about those two projects. We represent a lot of individuals on those projects, and so we'll do our best to convey what we're seeing. It's obviously when you have when you're representing sometimes 12 or 18 investigators, there's no possible way we can hit every single aspect of what's being funded on those projects. We want to give you a little bit of flavor about some of the things that we're working on with seedling disease, but also foliar disease, and some of the challenges that we have, and also some of the new things that we're learning about some of these pathogens. So when we think about the impact of pathogens, this is a slide that was developed by the data that was collected by Carl Bradley and Tom Allen and Jennifer Jones with the United Soybean Board, or Smith Buckland, summarized a lot of this information. So we borrowed this slide from her, and this shows this is the total millions of bushels lost for soybean cyst nematode. Here's Phomopsis, seed decay, frog eye leaf spot, seedling diseases. So we're going to be talking about seedling diseases on the first part of our presentation today. Here's 2 foliar pathogens. Here's sudden death syndrome, pod and stem blight, another important foliar issue, Phytophthora root rot, charcoal rot, white mold, and stem canker. And so those are some of the top ones, and this would be showing you, but depending on the weather, that's a big influence of what type of diseases you have in one year, or maybe how severe they are from year to year. So this changes a little bit, but there are some consistent ones that we have every year. Soybean cyst nematode, hot weather, it's bad. Moist conditions, it's bad, and there's other things like maybe charcoal rot. Obviously, depending on how much rainfall you have, you might even have less or more in a given year. So, I see you have a question.
Yeah. Why such a big swing in Phomopsis there? Is that weather?
That's a weather thing. So yeah, in 2017, I'm sorry. So this would be 18. So they had a lot of rain, and it also. We had more of a problem with Phomopsis in the Mid-South, upper Midwest than we normally do. And so just because of sheer numbers of acres, that really drove it. But
what's the geography?
This would be for the, that's a great question. This is for the total of the U.S. soybean production. So this probably gets to your question a little bit better. So this is the northern state, if you broke it down by northern versus southern. So here's seedling diseases. So usually plant pathologists, I'm guilty of this as well. When you say the word seedling disease, you think maybe 4 or 5 individuals. You think Fusarium, Pythium, those kinds of organisms. But it's way, way more complex than that, and I'll show you a little bit more information that's been gleaned from some of these USB projects. And here's Fusarium rot. Over, if you look in the southern states, here's taproot decline, here's seedling disease. So some commonality in terms of where they match up in terms of the importance in the north versus the south. If you focus on these are the ones that are foliar in nature, so quite a bit more diversity in at least in the namings of the diseases that we have in terms of they're not grouped just as a foliar group. We have these are individual diseases that are caused generally by a single organism. And so we see some commonalities across there as well. There are some foliar disease you have in the south that you would have them every year. Maybe they're a little bit more sporadic up in our part of the country. And then there are some that were traditionally southern diseases, things like frog eye leaf spot, that have spread all the way up into the upper Midwest, even into Canada. So it's a very interesting change that we're dealing with. And so when you break them down across the bushels lost, you can see the total bushels lost to foliar pathogens in the United States versus root diseases versus those that would impact both the root and shoot, those that attack the seed, stem and pod. So there's a lot of different ways you can look at that data, but the most important thing is these are very impactful problems, and some of them we don't have great management strategies for them. And that's the reason why that even though we might have resistant varieties or we might have foliar fungicides or seed treatments, why they are still causing so much loss, even when those management strategies are deployed. And so I want to focus a little bit on the seedling disease part of this USB funded initiative. And so this is just a picture. This was contributed by one of the investigators from Michigan State University. So how many people here graduated from Mississippi State University? Or have least, sorry. So I knew I'd at least have one of them here. So this is MISU, not MSU. They call themselves MSU, but when I see the word MSU, I always think about Starkville and the Bulldogs. So these are investigators. So you can see that this is the investigator from Michigan. We have Illinois represented, Tennessee, Iowa State, Kansas State, Kentucky, Arkansas, North Dakota. So a wide range of geography, but also of expertise. A lot of extension personnel on these projects, a lot of basic scientists, and also a lot of applied researchers as well. And so some of the themes, I don't want to go through all of these today. Obviously, we don't have time, but we're really concerned about how the environment impacts these pathogens. We saw that on one of those earlier slides, how that changes from year to year. The environment is such a big player in this. Also, some of the new things that people are doing with trying to deploy more cover crops. Those have a lot of benefits. Also, a lot of questions about how do these organisms interact with these cover crops. In some cases, cover crops can decrease some of these pathogens. In some cases, perhaps they're a host for the pathogens that we're trying to control in our corn and soybean rotations, or corn and other crops. And then also, so we're looking at the interactions with where you have maybe some seed health issues and how maybe seedling diseases are contributing to issues later on in the year with seed health, which is kind of a big window that you're looking at, something that's attacking the plant early on in the season, and yet there's still being some seed health issues later on when that crop is harvested. So not things that are bouncing from the ground on top of the pods, but it's something that was internal at the very beginning. So a lot of new work that's being done in that area. So the first thing I wanted to touch on was some of the work that the USB and the North Central and the USDA funded, looking at the diversity of what kind of organisms are coming out of sick plants. And so as I said early on, plant pathologists, we can sometimes look at plants and we'll say that's a Fusarium root rot or Rhizoctona. You can name a disease, but what's actually the organism? And to control it with especially host resistance, or in many cases with seed treatments, we need to have some specificity on the organism that's there, that we're isolating. So we sampled fields from many states. These are isolates that came out of sick plants. And so just to look at the oomycetes, these are things like the Pythiums and Phytophthora. In most cases, we saw lots and lots of species of Pythium. It's not just one Pythium species. So when you think about soybean cyst nematode or reniform nematode, that is a single species. So for Pythium, it could be many species. And some of those like cool conditions, some like cool wet, some like warm. So environment influences them. Some like certain soil types, certain rotation strategies. So it can be a very complex issue. And then also looking at the true fungi, we see over 26 genera that came out of these sick plants. And many of them were Fusarium species and not just one Fusarium species. So for the true fungi, but also for the fungal-like organisms, the oomycetes, a lot of diversity in species. So this surprised most of the scientists working on this because we're just like everybody else. We like to lump things together as that's a certain type of disease. And that's okay to do that in some ways, but to be specific to manage it, we do need to know what we're actually working with. And so this culture collection, obviously you can imagine over 3,500 fungal isolates. This is an ongoing thing that's yielding new discoveries, not only about pathogens, but also of maybe some other beneficial organisms that came out of those isolations. And so we have a lot of work looking at the impact of the environmental conditions on these pathogens, and just give a small view of some of this work. So this is showing some of the impact at various pHs and also temperatures. And we see in one case that the pathogen at the pH 7, at the temperature of 25 degrees C, we see much more loss at the higher temperature, and we see the inverse of that with that same pathogen at a lower pH. So that's kind of, how do you wrap your mind around that? So now every part, maybe different parts of the field, you could have this going on if you have different pHs, or from field to field, or from different parts of states, and when you think about temperature changes. But so this is just some of the initial work that we've done to try to start teasing some of this out, to see why you sometimes see seed treatments work very well in certain parts or certain times of year, and then other times of year they don't work as well. And so a lot of that's due to the environmental conditions and also the pathogen pressure that's in the soil. This is some work that is done at North Dakota State, looking at the impact of fusarium on plants. So this is a this is a controlled plant, nice and happy. This is a plant that was grown in the presence of fusarium. That's where FS stands for. You can see the plant's a little bit smaller. The root system is not as large. Also, it's a lot darker. Then we start adding different concentrations of soybean systematodes. So now the added stress on the roots, you can see a dramatic decrease in the plant's health. And so most of these things that we're dealing with as seedling diseases, they're not the only thing that's robbing the plant of its health or a condition. There's additional stresses out there. In our part of the world, in most soybean production parts of the country where you do not have cotton in the rotation, systematoad is in probably about 80% of the fields. So cotton does change that dynamic a little bit. But wherever we have fusarium attacking plants, we probably have we have nematodes and other fungi also attacking those roots. So it's not just a single thing that has to be looked at in terms of management. We're also looking at things like cover crops, green manure crops, looking at more diverse rotation schemes, looking at seed treatments and their impact on these seedling diseases. And so this is some work that came from University of Arkansas as part of this project. This is looking at the causal agent of a taproot decline. So what he was showing there is, at least in the laboratory, this is showing mustard, this is wheat, this is winter pea, and if you lighting's not the greatest in here, but what it shows is the seeds are colonized by that organism that causes a problem in soybean production. And so just because you see it in the lab does not necessarily mean that this is occurring in the field, but that would have to be validated in the field. So some of these, maybe even these new emergent diseases that are becoming more and more of a problem, we have to be very careful that things that we choose in terms of rotational crops or cover crops aren't going to make that situation more severe in our soybeans. So when you say the word cover crop, sometimes you can have different species within that cover crop, and in planting of the cover crop, in terms of what actually emerged, is a different story as well. So the diversity of species that came in there's a lot there that needs to be evaluated. And so, really to kind of summarize some of the efforts, this is ongoing every year. We have extension experts on this that represent each state. And so one of the first things that we did back in 2015, we did the fungicide efficacy guide. You might have seen this. It's sometimes, I wouldn't say the word repackaged, but it's within each university extension system, you'll see those efficacy guides be released. And so we update this each year as more and more compounds come onto market, as we have more and more data from the various testing that goes on at each university to be able to assign, how well do these various treatments work against various pathogens. And so this is one of the most downloaded publications on the crop protection network. And so this is probably, it's a little bit dated now. It was over 100,000 people in individual states have downloaded this, and probably you've seen these handouts in the past. And so this is continually updated, and so we have, in addition to just this information, through a lot of the extension talks and all, there's quite a bit of this information is released to the public.